Welcome back to free engineering tutorial on operating system. So in previous video we had studied about swapping. Now in this video we are going to talk about contiguous memory allocation. So what contiguous memory allocation will be doing is that we have to study first that how CPU address is generated. Okay, so firstly it will generate some logical address. Okay, then it will be checked with the help of limit register to give a protection that the generated logical address is in the limits of the permissible limit. Okay, after it is being checked, if the condition is yes, okay, if the logical address is smaller than the limit register, then it will move forward. But if it is not so, it will raise a trap. What trap is doing is that it will just signify that there is an addressing error and you need to check about the logical address. Okay, but if it contains yes or if the condition is true, then it will be added with the relocation register which we are getting from the memory. Okay, so the relocation register is totally a function of memory, and by adding the logical address with the relocation register we are getting our physical address. So basically there are two type of memories, means in which division is made. Okay, so this memory is divided into two parts. So first one is for the resident OS which is being reserved by the operating system, and the second one is the part of memory which is allowed to the user to be accessed. Okay, so the memory part which can be accessed by the user is known as user process or user partition, or the other part is operating system partition. Okay, and there are many operating system which are stored at the lower address, okay, like zero address, and the upper limit, if some operating system is stored at upper limit, then they will be governed like that. Okay, so there is no big deal in that, where in what we have to study. So now moving to memory allocation. So memory is allocated with the help of partitioning. Okay, so what partitioning basically means is that our main memory, okay, so this main memory is partitioned in different jargons. Like first one is fixed size partitioning. So this main memory is partitioned in the fixed sizes blocks. Okay, and if the process needs to be allocated, then this process will be coming here and it will be allocated to this partition. So this is the simplest one, and it is the fixed size partitioning. All the partitions are of fixed size. Okay, but that are not efficient. Okay, that we will talk about in next video, or in probably in next slides, what we call fragmentation. Okay, so there is a problem of fragmentation which we will study in next slide, in which memory is divided into fixed size chunks. Okay, so these are fixed size chunks. Now in the second case where we are getting our multiple partition. Okay, so in multiple partition scheme, the process which we are getting, these are like main memory is divided into unequal parts or unequal chunks, and the process which are coming, okay, so these are coming and will be allocated to this any of the sufficient memory part, and here the process will be stored, but the operating system will not keep track here. Okay, so there is a difference between multiple partition method and variable partition scheme, is that here in variable partition scheme, what will happen is that operating system will keep the track of the memory. Okay, but it is not so in multiple partition method. So what will happen in variable partition scheme is that the full memory will contain like whole. Okay, whole means empty block. Now if any process wants to come, then what will happen is that it will be allocated by the sufficient memory and will return back two types. One is stored memory, so this one is the stored memory by the process, and the other one will contain whole. So this will be the new state of the main memory. Okay, understand? So now the second part of the memory allocation is that there are three possibilities to fit a process in memory. So what three process or three methods are is that, firstly, let's say these are the partitions, and this is of 100 MB, this is of 150 MB, and this is of 200 MB. Okay, now a process of 90 MB is coming. So what will happen in the first fit is that the first encounter of the sufficient memory, we are allocating the process only to that memory. Okay, so what is the first encounter of the sufficient memory? This one is the first encounter, like 100 is greater than 90 MB, so it is available, or it can be allocated, this process can be allocated to this memory, available memory. Okay, so this will be allocated with the 90 MB. Okay, and this 10 MB will be empty. Okay, but it will not be the case in best fit. Okay, so best fit will check full memory and will get to know that what is the best fit for the requesting memory or requesting process. Okay, so firstly it will check which one is the smallest sufficient memory. Okay, so what is the smallest sufficient memory which is available in this main memory? It is 100. Okay, by chance it is the 100, but if there is one another memory, let's say this is 95 MB. Okay, so it will be checking in that, and it will get to know that 95 MB is the best fit for 90 MB, and the process will be allocated here. Okay, now in the worst fit it will check and go for the largest allocated part. Okay, or largest sufficient part. As you can see in this case, 200 MB is the largest sufficient memory, thus this process will be stored in this largest sufficient memory in worst fit. Okay, so worst fit is getting 200 and the best fit is getting 95. Okay,